Okay, so we start with chapter 1, matter and energy. Yes? Oh, I didn't see your hand. First name is perfectly fine. So chapter 1 topics, we will first look into matter and its classification, and then physical and chemical changes, properties of matter. Then we will look into energy and energy changes, scientific inquiry, and we will also have a basic math review. As I said, we would be using a lot of basic mathematical concepts, not a higher level, as you know that the prerequisite for this course is only Math 50 or Algebra 1. So it's not going to be the high math, but you need to have the basic math in order to finish the course. So yes. My power. No, I haven't put it yet. I want to ask you guys, do you guys want the PowerPoint, PDF PowerPoints? Okay, I can do that. So that if you want to print, you can print it before. Okay. So we will have a basic math review, and we'll talk about significant figures to be used in calculations, and then units and unit conversions. Because these things we will need in every chapter, so it makes sense to kind of have a review in the chapter 1 itself. So, matter is defined as anything that occupies space and it should have mass. Forms of energy are not matter. That is one of the common mistake we all make. We confuse between matter and energy. Matter should have mass and it can occupy space. Not that heat and light, for example, they are energy forms. They are not matter. They do not occupy space and they do not have mass. So that's the main difference between energy and matter. And we can classify matter so that we can understand it better. So if anything that occupies space and mass, we see a lot of things, right, which occupy space and mass. So in order to understand it better, we are going to classify it. So the first classification is matter can be divided into pure substances or mixtures. Now we will see what each of them are. So pure substances have uniform composition throughout. Uniform means same composition. It looks the same. And it's not only looking the same, the word is uniform chemical composition. So from every molecule to molecule, from every particle to particle, it has the same chemical composition. Whereas mixtures are composed of two or more substances that may or may not have uniform composition. So this uniform chemical composition is not a must for mixtures. So once again, pure substances have the same composition, and from sample to sample, if you take a sample from here or there, let's say for example water. Anywhere, water, if you take water from anywhere, the chemical composition is H2O, 2 hydrogen atoms and 1 oxygen atom. It doesn't change. So that is a pure substance. Now pure substances can further be divided into elements and compounds. And element is a substance that cannot be broken down further into simpler substances, even by a chemical reaction. So let's say for example, if you take gold, the pure gold metal, it's an element, and we can break it down to smaller particles, okay, but it cannot be broken down into a different substance. If it's a big chunk or a small chunk, you take it, it's still gold. Now, elements can further be separated into metals and non-metals. Metals and non-metals, no need of any explanation as the word suggests. And compound is a substance which is composed of two or more elements and they are combined in a definite proportion. So a compound has to contain at least two different or more elements, and they will always have definite proportion. The way two elements come together, how many of each, that proportion is always going to be definite in a particular compound. So element, as I said, it cannot be broken down into simpler substances, and all known elements to us are arranged in periodic table. So here is a picture of the periodic table from your book, and we have a periodic table there on the board also. You are not supposed to memorize the periodic table or anything, okay? In your exams, I will always provide a periodic table. A periodic table just like this would be attached to your exam. Now, a periodic table contains a lot of information. As we go further in the course, we will learn in more detail about what are these numbers, what is the meaning of each of those things. Even though it just looks like some symbols and numbers, it contains a lot of information. Okay? So periodic table, as we just said, the main classification is metals and non-metals. We will usually find metals on the left side of the periodic table. Most of the elements on the periodic tables are metals, but we do have some non-metals also. Let's say, for example, here in this periodic table, all you see in this blue, even these two different shades of blue, all you see in blue color is metals. What you see here, the yellow color, that is all non-metals. And there is a small subcategory also, something which we call metalloids. We will learn that more detail, what are metalloids later. This green you see in between in that stepwise fashion, those are called metalloids. So mainly they are metals and non-metals, elements in the periodic table. So far this is what we classified. The pure substance, we can either call it elements or compounds. Remember, compounds should contain two or more elements, and then elements can be further classified into metals and non-metals. Now, what are atoms? This is a word we are going to Is the window open, guys? It is? Maybe we should close it. So anyway, the room is air conditioned, so thank you. That makes it better, right? Okay. So an atom is the smallest unit of an element that retains all the chemical properties. So if you take an element, say for example, this is a picture of copper wire. Okay, we have seen the copper wire roll, right? And if you look into that copper wire through a very powerful microscope, like scanning tunnel microscope, you would see the copper atom. Usually atoms are in spherical shape, and this one single sphere, we can say that that is one single atom. And an atom is the smallest unit that would retain all the properties of copper. Atoms can further be divided into subatomic particles. We will learn them. We'll learn about subatomic particles in a while. But subatomic particles do not retain the properties of the substance. So atom is the smallest unit that would retain this properties. Now on the periodic table we have seen a lot of symbols. So the element symbols often contain one or two letters of the element's name. Say for example carbon, one of the very common element. And carbon is represented by the symbol C. Well, carbon starts with a C, so makes sense. Now let's say we take another one which also starts with a C, calcium. So you can't again represent calcium by C, right? Because you have a confusion now. C for carbon or C for calcium. So we will add the second letter also, Ca for calcium. And this is the trend for most of the elements. Okay? They are one letter, the capital letter start with the name, or maybe two letters. But then you would see some elements starting with different symbols. Say for example copper. If you take this principle, it should be Co, but the symbol you see on the periodic table is Cu. Gold nowhere represents, when you look at the symbol, you have no way of knowing, oh, I can connect this to gold. The symbol is Au. So there are a lot of other elements like this. These are some of the examples, and these names or these symbols comes from their Latin names. Okay, so copper is called cuprum, that's where you get the Cu. Gold is aurum, that's where you get Au. And another common one, silver, the symbol is Ag, because the Latin name of silver is argentum. Iron, the symbol is Fe, because the Latin name is ferrum. So like this, there are some of the elements whose name and symbol do not bear any resemblance, because the symbols originated from the Latin name. Now this periodic table, the symbols which are shown in this yellow, the book says know the names and symbols of the most common elements indicated. These are the elements usually we will see when we study chemistry. Usually we will see in chemical reactions and equations we are going to see. However, I'm not going to be very particular about your by hearting all the stuff. As I said, I would provide you a periodic table, and I have seen this as we proceed in the semester. You would start getting some of the names and symbols the moment you see them on the periodic table, because you would use them so often that you will know them. Just look at them and you will know, oh okay, O is for oxygen, and where it is in the periodic table, you will start knowing them. Okay? But these would be the main elements we would be using. Okay, so we said atoms represented by a single sphere is the smallest unit which retains the chemical reaction, and the next term we are going to look at is called molecules. So a molecule is formed when two or more atoms are combined together. So the atoms bound together in a molecule could be from the same element or from two or three elements based on what compound it is, whether it is a pure substance or it is a compound. So the first picture here you see each molecule, we call this one molecule. Each molecule, how many atoms do we see here? Two. There are two spheres joined together. So this is atoms of a same element joined together and made a molecule. What do we see here? We have three atoms. Are they all from the same element? They are not. We see that two of them are from the same element, but right in the middle, that's from a different element, right? But this also is a molecule. So a molecule is two or more atoms together. It doesn't matter whether atoms are from the same element or from two or more different elements. Now, a compound is a pure substance composed of two or more elements combined in a definite proportion. So, that second picture we have seen, three different elements, one black and two red dots, that we can call a molecule of a compound. So, for a compound, you need to have two different elements or two or more different elements, and they should be combined in a definite proportion. And a compound can have properties that are different from its component elements. Say for example, here is a chemical compound known as iron pyrite. Okay, here is the chemical formula. You don't have to worry about that right now. Let's just focus on the appearance. It's like, shiny blocks, this compound. This is like not this big, it's small crystals. If you look it through the microscope, you can see like big, shiny compounds. And iron pyrite is formed by two elements combining together, sulfur and iron, two different elements. If you look at sulfur and iron different, sulfur is this dull looking, kind of a sticky, chalky powder stuff, as you can see here. This is sulfur. And iron, pure iron is, of course, those are also dark color, not very shiny. See, there are iron, small iron particles sticking to a magnet. So this is the appearance of sulfur and iron alone, but when they combine in this particular ratio, like every 2 iron with 3 sulfur atoms, look at the appearance. The compound can have an entirely different appearance. Now, another substance which we all play with, pure sand. Not just the beach sand. Beach sand is mostly pure sand, but there might be a lot of other stuff also in it, right? So when we say pure sand, sand which is pure, which is maybe filtered and washed and all that. The formula of pure sand is silicon dioxide. The name of pure sand is silicon dioxide, and the formula is SiO2. Now start asking these questions to yourself. When you look at this formula, what does this tell you? What is the combination of elements in sand? Well, there are 2 elements, yes, silicon and oxygen. How are they combined? What is the ratio? 1 part silicon to 2 oxygen, right? So for pure sand, this will be the combination. 1 silicon atom with 2 oxygen atoms. If it is 2 silicon atoms and 2 oxygen atoms, that is not sand. So any other combination of silicon and oxygen, we cannot call it sand.
All of the lack of a better word, nomenclature on the periodic table is represented in units of atom.
Yes, that represents 1 single atom of each element on the periodic table. When you have yes. So, here is an activity. Identify each of the following as an element or compound. So, remember what is a compound? 2 or more elements. That's all you need to remember. So, the first one, it says He. What do you think? Helium. That is just an element. It's only one element. H2O, that is a compound. There is hydrogen and oxygen. Sodium chloride. Name sounds like 2 different things, right? Sodium and chlorine, compound. How about copper? That's only an element. There, you answered right. Now let's look into what are mixtures. So, a mixture, remember, that is also a combination of 2 or more elements or compounds, but how are they different from pure compounds? Because pure compound is also 2 or more elements combined together, right? But a mixture is different from pure compound in such a way that the components of a mixture can be separated by physical processes. No need of doing a chemical reaction to separate them. Say, for example, salt water. Salt dissolved in water. That is a mixture. How can we separate its components? Water and salt. Dry out or evaporate the water. That's just a physical process. You are not doing any chemical reaction there, right? Another example is brass, which is an alloy of copper and zinc. Well, there are 2 different elements there, copper and zinc, 2 metals. They are combined together and make brass. How do we separate the components? Heat it. 2 metals have 2 different melting points. So whichever has the lowest melting point will melt first, and you can collect that. So you have the 2 metals separated. So heating, boiling, melting, those things are all physical processes, not chemical processes. right? Again, we will look into more details what are physical states and physical processes, but this is the main difference. Mixtures can be separated into its components by physical process, whereas pure compounds, we cannot separate them by physical process. If you want to separate the pure compound into its components, you have to do a chemical reaction. So salt being separated by evaporation. So this is how you make the sea salt. What you do is you have big tanks, areas where you collect seawater and just leave it in the hot sun. The water would be evaporated and what you are left with is big chunks of sea salt. So mixtures, we just talked about mixtures which can be separated into components by physical process. Again, mixtures can be divided into two different types: homogeneous mixtures and heterogeneous mixtures. So homogeneous mixtures are also called solutions because they have a uniform composition throughout, like salt water. If you take a glass of water, you put a teaspoon of salt in there, you stir that and made the salt dissolve completely. That is, when you look at the glass, it looks the same, right? Once the salt is dissolved, whether the top part of the glass would look different or the bottom would look different. Can we see any difference like that? No, it would all look the same. So that is a uniform composition. That is a homogeneous mixture. Whereas heterogeneous mixtures do not have uniform composition throughout. Let's say potting soil. The potting soil you buy. You just open it and you would see different things in it, right? And do they exactly look the same? That is, if you start counting, how many of those, the white chunks you see everywhere through the sample. There are some areas you might find more of them, some areas it's just more of dirt, things like that. Or when you make cakes, mix at home. Let's assume you are not using a high-powered mixer. Let's say you are mixing it by hand. It's not uniform everywhere, right? So, well, Michelle, Alyssa is disagreeing? No? Okay. So that is what you mean by heterogeneous or homogeneous mixtures. So let's do an activity. These are different mixtures given here. Let's try to classify them as homogeneous or heterogeneous. Salt water, we already talked about that. What do you think? That's homogeneous, right? Because once the salt is dissolved, it's just the same. How about lake water? We can say heterogeneous. Let's say I have filtered out all the, algae and leaves and all that stuff. Then it would become homogeneous. Okay. How about tap water? Again, filtered. No rust particles. Homogeneous. Okay. How about air? Okay. Well, again, on a good day, not on a windy day with all the leaves. How about the brass? Think twice. How do we differentiate between homogeneous or heterogeneous? Uniform. Once it is combined to brass, it's kind of uniform, right? Right? Okay. Potting soil and cake mix, we already just talked about that. So, what are they? They are heterogeneous. So, yes. So, with the asterisk it says depends upon the presence or absence of suspended solids. That's why I said the lake water and, tap air is all filtered. Okay? So, once you filter them out, they become homogeneous. So, this table or figure 1.7 from your book gives you the classification of matter we have seen so far. Let's go through that one more time. So, we started with matter, which is defined as something which has mass and can occupy space. And then if we can physically separate matter into its components, then we will say it's a mixture. If we cannot physically separate matter into its components, then we will say it's a pure substance. Now since this side is the smaller one, we will finish this first. So you have a mixture, then the next question is whether it is homogeneous or heterogeneous. How do we differentiate that? What is the key word? It's the same throughout, or the uniform composition throughout. If it is uniform, then we will say it is a homogeneous mixture, or the other name of homogeneous mixture is solution. If it doesn't have a uniform composition, then it's a heterogeneous mixture. Now, when we come to the pure substance, whether we can decompose it. Decompose means what? What is the meaning of the word decomposition? Break down. Can we break it down chemically or not? If we can, then it is a compound, because a compound contains two or more elements and we can break it down by a chemical reaction. So if you can break down something to its components by a chemical reaction, then we will call it a compound. Otherwise it's an element. Elements, as we said, we cannot break it down to further simpler compounds, right? So that is an element. Now, how do we usually differentiate between non-metal and metal? Whether it would conduct electricity or not. Okay, metals will conduct electricity and non-metals do not. One exception is graphite. Graphite is made of carbon, which is a non-metal, but graphite in this form of carbon, it will conduct electricity. That is why graphite is given as or graphite. Graphite is not a metal because it is composed of carbon, which is not a metal, but carbon in this form, that is graphite form, it can conduct electricity. So this is the classification of matter. Questions so far? Yes.
Sounds really stupid, but what about water?
Water is a compound, a pure substance.
Okay. But we're talking about electricity, conducting electricity.
It doesn't conduct electricity. Pure water doesn't conduct electricity.
Okay.
Don't worry, you will get to test that. Okay? Physically, you will get to test that in the lab. Usually when we say, oh, water conduct electricity, it's not the pure water, the H2O conducting electricity. It is other things dissolved in water is the culprit. Okay? So when we say water in chemistry, it is H2O.
So if somebody's sitting in a bathtub, somebody comes by and
Your bathed water is not pure H2O. It has a lot of things. We don't see it with our eyes, but
Substance around you which you're laying upon, which is a conductor of electricity. So it's not the water.
but the only thing separating you from the electricity is the water. That's the
so as I said, the water you are talking about is, see, now onwards guys, you are chemistry students now. So you have to come out of that, regular stuff we talk outside just when we say just water or just salt. No, we are going to be more specific now onwards. When we say water here, we mean H2O, nothing else. But in the bathtub, what you are filling from your tap is not pure H2O. Most of it is H2O, but there are a lot of other things dissolved in it, which we don't see. And those are the culprits which there are a lot of metals and minerals dissolved in it, which would conduct electricity. That is how you get the electric shock. Okay? So let's use the, this is how it will work. We'll kind of discuss about a topic and we'll have a clicker question. So whoever has the clickers today, take it out and let's see. Okay? Now even if you haven't registered, go ahead and just click, because this is not part of your grade now, we are just practicing. And in order for the registration to be complete, you need to use the clicker at least once in the class. So take it out and let's use it. So this is how it will work. When you see this slide, you will take out your clickers, turn it on, and then in the next slide I will give your clicker question. Okay? So don't start answering because I haven't started the clock yet. Please answer only after I start the clock. So here is the question. Bill and Anna, those are the two characters, in the book. They start with Bill and Anna exploring things. So their class rings are made of white gold. Okay, not the pure white gold, that's why it's given in quotes, white gold, which white gold is usually two elements, gold and palladium. Bill's ring has a different ratio of gold and palladium compared to Anna's ring, but both have uniform composition throughout. How would you classify white gold? That's your question. So there are four options. Think through it and then you can choose your answer. So see, once I start the clock, so just like that, when people are pressing your answers, I see the display changing, right? So I don't think you need much time, but let's say 1 minute. 1 minute might be too much. You might be getting bored. Okay, how many people have clickers today? Please raise your hand. So 1, 2, 3, 4, 5, 6. So I might see 6 responses. I see 5. You didn't use it? Yeah, you need battery in it, so it's okay, that's fine. Now, another thing is, let's say for example somebody chose an answer and decided that okay, that was the wrong answer, I want to change your answer. Go ahead and change it before the clock stops. The box will register your last response from the clicker as your answer. Yes? That's fine. As I said, in order to register this, you need to at least use it one time in class. You have to go and register it, yes. Otherwise, it won't start showing up in your grade book. You have to read that announcement I have posted on the announcement page. You have to go to iClicker.com and choose the registration. And from there onwards, it's just a couple of easy steps. Putting your ID. As I said, put your online ID. That is not your CM Connect ID, okay? The online ID for clicker is your first name, middle initial, last name, all lowercase, no comma, space in between. That's your ID. Again, that is, I have specified that on the announcement. So they register that and then you will have to enter the unique ID on the back of your clicker. Every clicker has a unique ID. So I would suggest put a tape on that ID so that by usage with your fingertips and moisture and all that, you won't lose that ID, because every time you register your clicker for a course, you need that ID. Okay? Alright, I was saying 1 minute, but since we started talking, we didn't stop the clock. So let's say it was 1 minute or it was this much time. So we stop the clock. If you press your answer now, it will not register. Okay? So you have to press your answer before it is done. And now I can go to the display and see how you did. So one person answered A, 4 people answered C, and D is one choice. There is no B and E. What is the correct answer? Of course, it is not a pure substance. Why it is not a pure substance? The pure substance also has 2 or more elements, but they are combined in a definite proportion, like water. It's always H2O, 2 hydrogens with 1 oxygen. If it is 2 hydrogens and 2 oxygen, it is not water. It is a different chemical compound. Okay? So for pure substances, the composition, the chemical composition is definite. Here it says it contains 2 elements, but Bill's rings gold palladium ratio is different than Anna's ring. What does that mean? Is that the chemical composition, is their chemical composition definite? No, they are different. That means it is not a pure substance. It is a mixture. Now we are going to think about heterogeneous mixture or homogeneous mixture. It says it has a uniform composition throughout. That means it should be homogeneous mixture. So your correct answer is C. Now when I click on C, people who answered C will get the full points. People who, what? Well, other people do not get any points, but still your attendance is registered. That is the advantage of clicker. Whether you answered correct or not, if you have responded, your attendance is registered. Now, the question you got it right or not, well, you will get, if you got it right, you get the points. If you don't get it right, you don't get the points. As simple as that. That's all. Then we will move forward. Yes.
On that, how could they have a uniform composition if they have different grades with two different elements? Would they not have a different composition?
Different chemical composition. Uniform composition throughout means the same look throughout. When you look at it, it looks the same. It doesn't show where the palladium is or where the gold is in the ring. Once it is mixed, like brass, copper and zinc, once it is mixed, it looks the same. But you can buy different grades of brass, with more copper, with less copper.
It's not saying that the rings look the same, it's saying that each ring, like, both rings don't look like each other. You know what I mean? They're, yeah. They don't look like each other, but each
Well,
one
actually, to the
is
eye, they look the
homogeneous.
same to the eye.
It might look the same to the eye, yeah, I mean there may not be much difference.
But like, it's saying that each ring is homogeneous, not that they're homogeneous together.
No, each ring is homogeneous, yes. Each ring is homogeneous. Okay? So once we do this, then I would make this go away and we would proceed to the next slide. Or if we have a second question, we will proceed to the second question. That is how the clickers will work.
And you can press 3 times for 3 different letters, but it will only record that last.
It will record whatever you press last. Okay, keep that in mind. So that is for you to change your answer in case somebody just answered as pure substance and then read the question one more time and oh okay, maybe it's not, I want to change my answer. That is why that option is there.
But in 30 seconds, you're going to be a quick reader, huh?
Well, that is correct. We have to be, well, usually before I start the clock, I would kind of read the question loudly in the class with you. So you are reading the question and then only I would start the clock. I won't take time out for reading the question from the clock. No, I mean, what were the experiences? You have used it, right?
AMP 1 and 2 on the 6 batteries.
Okay. Remember, once you are done with the switch it off, because I think that is one of the things people forget to switch it off. And if you just leave it on without using, just like any other devices, you might. Okay. I think I had only one time last semester somebody's battery died and somebody answered, and can I use her batteries? And somebody opened it, but the batteries changed and answered. I haven't seen that very often, and I don't think if you use it, wisely, as I said, use it, turn it off. I don't think the battery is going to die out fast. Okay? All right, so what time is it? 9:25. You know what? We should stop right here, but I need the attendance, guys. That is one mistake I did. I should have done that in the first F10.